Hello students, this is my 8th video on the chapter solution and today we'll discuss about the vapor pressure. So for vapor pressure we have to take the liquid in a closed container, not in an open, in a closed container. For defining vapor pressure we have to take the solution in a closed container, not in open vessel, open container. So if you're heating the liquid, what will happen? The molecules of liquid will come into the vapor and they form vapor, and in this case the vapor pressure of the liquid is denoted by P naught A. That means it's the vapor pressure of the pure liquid. I have taken here pure liquid, and a point is reached here where you can see that here evaporation is taking place, and in this direction the molecules will come into the liquid, the vapor molecules will come into the liquid. That is called condensation. So equilibrium is established, where the rate of evaporation becomes equal to the rate of condensation. That means liquid goes to vapor and vapor goes to liquid, where equilibrium is established. So in that condition we can define the vapor pressure now. So the definition here: the pressure exerted by the vapors, above the surface of liquid in equilibrium with the liquid at a given temperature. The pressure exerted by the vapors above the surface of liquid in equilibrium with the liquid at a given temperature is called vapor pressure. This is the definition of vapor pressure. Now we can see the factors affecting the factors affecting the vapor pressure. Factors affecting vapor pressure. So there are some factors which can affect the vapor pressure of the liquid. The first factor I'm taking here, temperature. First factor is temperature. So you can see on increasing the temperature, the evaporation will take place at the higher rate, because in that case the molecules of liquid will gain the energy. That means the kinetic energy will increasing, and the vapor pressure of the liquid will be higher, because the vapor pressure will depend upon the number of molecules in the vapor. So in that case increasing the temperature, the vapor pressure will be higher. So that means we can say that the temperature is increasing, vapor pressure is also increasing. Temperature and vapor pressure, the temperature is directly proportional to the vapor pressure. And the second factor, nature of the substance. Nature of substance. Which type of substance we have taken? Nature of substance. Suppose I have taken the substance here, ether. That means examples I'm taking here: CH3O, CH3. It is a dimethyl ether. Ethanol having formula C2H5OH, and water. So we have taken three types of liquid. One is the ether, ethanol, and water. So we know very well about water. Water forms the hydrogen bonding between the molecules. So water can form 4 hydrogen bond. 4 hydrogen bond around it, and ethanol can form only one hydrogen bond between the molecules. Ethanol also form hydrogen bond, but it form less hydrogen bond and it form more hydrogen bond, and ether can't form hydrogen bond, no H bond in this case. So if the force of attraction is weak between the molecules, vapor pressure will be higher. Vapor pressure will be higher. So we can say that the vapor pressure of ether CH3O CH3, vapor pressure of dimethyl ether, vapor pressure of ethanol C2H5OH, and vapor pressure of water. The order will be what? Those liquid which have low force of attraction between the molecules will have higher vapor pressure. So we have seen dimethyl ether has no hydrogen bond, interaction is weak as compared to ethanol and water. So the order will be like that. Dimethyl with ether will have the highest vapor pressure as compared to ethanol and water. So we can say the vapor pressure is inversely proportional to the force of attraction between the molecules. If the force of attraction between the molecules is lower, the vapor pressure will be higher. So here I have taken different types of liquid. Now I am taking the substance which may be volatile and non-volatile. Substance which may be volatile and non-volatile. Substance which may be volatile and non-volatile. Volatile and non-volatile. Volatile and non-volatile, that means volatile, that means ki those liquid which have tendency to evaporate, those substances which have tendency to evaporate are called volatile substance. Tendency to evaporate, that means they come into the vapor, are called volatile substance. And those which have no tendency to evaporate, are called non-volatile substance. Okay, so volatile substance are those which have tendency to evaporate, and non-volatile substance which have no tendency to evaporate. So volatile substances are mainly liquids here. They are mainly liquids, and liquids we know very well, they will come into the vapor, they can form the vapor, they can evaporate. And non-volatiles, we can take solids. Solids are non-volatile, they will not form the vapor. Okay, so if you have volatile substance, so in that case the vapor pressure of the liquid, that means the vapor pressure of the pure liquid, will not equal to 0. They will come into the vapor, so they have some vapor pressure, but in case of you have non-volatile substance, so they will not form the vapor. That in that case the vapor pressure will be equal to 0 because they do not form the vapor. So I am taking the example of volatile substance and non-volatile substance. So example of volatile substance which can be used in this chapter, here water, ethanol, benzene, etc. These are called volatile substances because they have tendency to evaporate. But I'm taking example now for non-volatile substance. The example of non-volatile substance for this chapter is glucose, sucrose, urea, etc. So these are non-volatile substances. They cannot form the vapor, and in this case the vapor pressure will be 0. Now the third factor is boiling point. Boiling point. Lower the boiling point of liquid. Lower the boiling point of liquid. Higher will be the vapor pressure. Higher will be the vapor pressure. Boiling point determines the force of attraction between the molecules. So we have seen in the second case where the boiling point, the force of attraction of those liquid is high, so that they will have a low vapor pressure. So we can say that lower the boiling point of liquid, higher the vapor pressure. That means the vapor pressure is inversely proportional to the boiling point of the liquid. Boiling point of the liquid. So I'm taking example here. Water, you know very well, boiling point of water is 100 degrees Celsius, and ethanol C2H5OH, it has 78 degrees Celsius temperature. So those liquid which have low boiling point will evaporate easily. So in this case ethanol will evaporate easily as compared to water. So ethanol will have the higher vapor pressure as compared to water. So we can say that the vapor pressure of ethanol C2H5OH is greater than that of vapor pressure of water. And the fourth factor is purity of liquid. Fourth factor is purity of liquid. The liquid is either pure or in solution. We'll talk about the pure liquid, the vapor pressure of pure liquid and solution. So the pure liquid has always higher vapor pressure as compared to its solution. So I'm going to explain this. Suppose I've taken a pure liquid in this container. Pure liquid, suppose I'm taking liquid A in this container, and in another container I'm taking solution here. I'm taking solution. That means I'm taking two liquids, liquid A and liquid B. Liquid A and liquid B. So here I have taken a pure liquid. The pure liquid I have taken here in this container, and solution I am taking here by mixing the non-volatile substance in the liquid, and we have the solution now. So liquid A, you can see here the vapor pressure of pure liquid will be represented by the P naught A, and the vapor pressure of that liquid in solution is represented by PA. So what's the reason? In the solution the liquid will have the lower vapor pressure. Here we can see here this is the pure liquid, and in this pure liquid the entire surface is occupied by the liquid molecules. Only but in the solution we can see the entire surface is not occupied by the pure liquid. So in this case the vapor molecules will come less as comparison to the pure liquid, and we can say that vapor pressure of pure liquid is greater than that of vapor pressure of that liquid in solution. So this is about vapor pressure and the factors on which the vapor pressure depends. And the next video will discuss about the Raoult's law for volatile and non-volatile solid. Thanks.